You're not going to be super happy with your Juniper device unless you can completely configure its interfaces. And there's a lot more to Juniper device interfaces than meets the eye, potentially. Let's explore this important topic in this nugget. So when it comes to our interfaces on our Juniper devices, get ready to be flexible with what you think you're going to see, because things are going to vary pretty dramatically from Juniper device to device. Some kind of constants that we can speak of here is that you need to configure them in order for them to show up when you're looking at your interfaces. There's permanent physical interfaces on your device, and there's transient interfaces that can be created based on features. Each interface that's permanent is going to have a physical config versus a logical config that we're going to make. And then there's lots of different types of interfaces with Juniper. There's management interfaces, for example, and this is for out-of-band management of the device. The specific interface you would see would be platform specific. For instance, you may be on a device where the management interface is FXP0, or you may be on a device where it's ME0. It all depends. There's internal interfaces. This is for connecting the control plane and the forwarding plane. Again, you might see this as FXP1 versus EM0, depending on what type of device you're on. There's, of course, our network interfaces for things like ATM and T1 and DS3 and Sonnet and Ethernet. There's services interfaces. These are going to provide one or more user configurable services like encryption, tunneling, link services. So we might have a multicast tunnel interface. We might have a GRE tunnel interface. We might have a virtual loopback tunnel interface. And speaking of loopbacks, that's another category. So we have 1, 2, 3, 4, 5 categories of interfaces here. Loopback interfaces like LO0, for instance, are a great way for us to provide an interface on the device that's hardware independent. Any physical port can respond on behalf of that loopback interface. So your particular Juniper device might be nicely equipped with a network interface of GE for Gigabit Ethernet. Now remember, you're going to have physical versus logical parameters you can assign to that interface. What would be an example of a physical parameter? Well, how about speed? Or how about duplex? What would be an example of a logical parameter? Well, this is where we have our protocol families and the appropriate configuration. So you might say iNet for a layer 3 interface, that's the protocol family, and then you would give an IP address as part of the logical configuration of that particular interface. If we're dealing with an Ether type interface, a layer 2 interface on your Juniper device, then obviously the logical properties that you would give would be something like a VLAN that is assigned to that particular interface. Now, a naming convention is used so we feel comfortable, no matter what Juniper device we're on, with the particular interface that we're dealing with. TT here stands for the particular media type that we are utilizing. A great example, of course, would be GE. That would stand for Gigabit Ethernet. Then we have our chassis slot number. Then we have our card number in that slot. Then our port number, and then our logical unit number. Remember that all numbering is going to start at 0. So a typical example would be Gigabit Ethernet, 0, slot 0, card 0, port 0. Notice we have a logical unit number of 0, but we don't need to specify it because it is implied. So we don't have to do that. We could just say Gigabit Ethernet 000, and we're in the logical unit number 0 by default for that particular interface. So let's bring a lot of this theory home at the command line. First of all, one of those great commands that you can utilize on the device. Notice we're in operational mode here on our Juniper device. This is an SRX gateway device. You would kind of think that this device would have a lot of different physical and non-physical interfaces, or permanent and transient interfaces, and you would be right. Watch this. If we do show interfaces terse on this device, what a great command to get a summary of interface information that's on this device. Here's just some of them. So we can see a lot of different interfaces on this device. Some are in the layer 3 family and have IP addresses assigned. Others are not assigned any particular parameters. Notice we get a nice up, down, or up, up status for the layer 1, layer 2 states of these particular interfaces. And now, of course, to answer one of the big questions that we might have, how do we manipulate the physical parameters of the interface versus the logical parameters of the interface? Well, watch. Obviously, from operational mode, we'll do our configure command, and then we do edit interfaces, and we can select the particular interface that we want to manipulate. Remember, we can see its general status with the show interfaces terse command. But here I go into the Gigabit Ethernet 0/0/1 interface, and we can manipulate it. Under the interface itself, we can set the physical properties. So if I do a set question mark, we can see like encapsulation, the physical link layer encapsulation that we're going to utilize on this particular device, or the MTU, or to code a unique MAC address, software delivered MAC address. You get the idea. These are those physical properties that we spoke of. We would find certainly speed and duplex settings here. Now, those are the physical settings. Notice going right under the interface name with our edit. If we want to manipulate the logical properties, we go under the unit number, that logical unit number. And if we're not using subinterface concepts, it would be unit 0 that we edit. So I could say edit unit 0. And now notice we're going to be able to set the logical properties of this particular interface. So if I do a set now, one of the things that we're going to see is the family command that will allow us to configure a particular protocol family. So I could say set family, and I could say iNet, or let me show you the families. One of them is going to be iNet for IPv4 parameters. Notice iNet 6 for IPv6 parameters. So I could say iNet for the IPv4 parameters, give a question mark here, context sensitive help, and looks like our access just hiccuped. That's okay, it returned. And so notice that set family iNet question mark would give us the address command. Sure. So we say address question mark, and it says, all right, give the address. So I could give this particular interface the IP version 4 address of, how about 192.168.1.100, and we can do the prefix notation when we set this. So we have just made the logical configuration change of a layer 3 IP address to this particular interface. Verification? Well, sure, I can just do a show in this section of the hierarchy, and we see we have added the layer 3 address to the logical parameters of this interface. Now, if you do your verification and see that you've fat-fingered, you've mistyped the particular IP address, be careful about using the set family iNet address command again, because Juniper interfaces by default can take multiple IP addresses, and they'll even form protocol adjacencies over those multiple IP addresses by default. So we're not interested in setting a family address here. We would be interested in doing a rename. So we'd come in and we would say rename and we would say family, inet, address, and we would give the old, which in our case was 192.168.1.100/24, and we would name that to address, or rename it to address 192.168.1.1/24. We'll show our configuration at this point. We see that we have properly renamed the address. And of course, we can't forget we would want to commit this particular configuration in order to make this candidate configuration the new active configuration. Now it's at this point that something else may be bothering us a little bit in this nugget, and that is how much work it would be potentially to go into interfaces, configuring them one by one with physical and logical properties, especially when we're dealing with a Juniper like layer 3 switch, which is going to have lots and lots of potential interfaces. Well, the great news is we can use what are called configuration groups. You'll often hear engineers refer to these as interface ranges because of the syntax that we're going to use to create them. I like to call them configuration groups, however, and so does your exam blueprint, by the way. So what you do here is you go in your configuration mode and you say edit interfaces. So edit interfaces, we go into that portion of the hierarchy and we say set interface range, and we give it a name like users, and then we say the member range for this configuration group that we're creating is, maybe it's gigabit 0/0/1 to gigabit Ethernet 0/0/3, or whatever your range might be. And now we create a nice group of physical interfaces called users, and now we can edit that. You go in and you say edit interface range users, and now we're in that portion of the configuration hierarchy, and we can apply configurations to all of those interfaces. If there are individual configurations under those specific interfaces, you have a potential for conflict, and the most specific setting will indeed win out. So my daughter, with her love of popular radio, has tortured me for the last, I'd say, 18 months with a song, It's All About the Bass. This nugget was all about the interfaces. We saw that there were permanent and transient interfaces on our devices. We saw the interface numbering or naming scheme. We talked about physical versus logical properties, and we even saw the nice configuration group feature that we can utilize. I sure hope you found this nugget informative, and I'd like to thank you for viewing.